Math, 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 math. Welcome to math. I'm your host, Mr. T-Dog, coming at you with lesson 88. How'd you guys like that as an opening? Change it up a little bit, get a little oomph in there. Yeah, I bet you super love that. Let me know in the comments below if you were scared and I surprised you. Okay, new concept. Increasing knowledge. Let us review these three important ideas about proportional relationships. So two variables, okay, that can change interdependently, right? So it's always like a fraction. As one changes, the other one changes, okay? Constant factors. So here they describe it as y equals kx. You're going to see a lot of something close to this. Like, you're already familiar with y equals mx plus b, which is also a proportional relationship of graphing. This is not going to be too far off. In a table of values for the two variables, all pairs form equal ratios. That is, proportional relationship in the ratio constant. A lot of words. Basically, it means that whenever, no matter what y and x are, okay, no matter what they are at all, the y over x will always have the same ratio. Okay, so when we're talking about y equals mx plus b, that always gives us our constant slope. Okay, no matter what the two numbers are, they turn into the same fraction. Just like how 1/2 is 2/4 is 3/6, so on and so forth. Okay. Think of K for constant of proportionality. A graph of proportional relationship is linear and aligns with the origin. Okay, so constant. This one, of course, is changing. Okay, these guys are constant. This is a not proportional, non-linear. It is exponential. Okay. Following effects, as long as there's squares in all of these, okay, they're always going to be the same. Let's see. We'll say, so this over here, right, is proportional, okay? This one over here, because it involves multiplication and essentially 5 times 5, 4 times 4, right? It's exponential, not proportional, okay? Proportional relationship, not proportional relationship. It doesn't mean that there's not a connection between the numbers. It just means that it's not something you can graph as a straight line, okay? Proportional relationships are straight lines on graphs. And specifically, are straight lines through graphs that start at 0. Okay. So what that means is, if I had a graph that was at y equals mx, okay, plus 0, okay, that would go through 0 and then it would have a straight line, proportional relationship. However, if I had y equals mx plus anything, okay, any number that wasn't 0, plus 1, -1, 2, anything, okay, it's not technically considered a proportional relationship, because even though the slope is going to be proportional, the your graph is not going to show the same ratio each time. Okay, so Proportional relationships, straight lines through graphs start at 0. Okay, that is exactly what that is. Two methods for finding height. Okay, so here they're able to figure out if 2 is 15, then what is 3? 22.5. Okay, nice and easy. This is the way I like to do it personally. Makes sense to me. The other option is figuring out essentially that ratio and then just multiplying it. Okay, both work. I think you guys will do okay on this. I'm going to do the practice set for you in a different video. But yeah, your written practice today. I'm going to do 2 through 24 even today. A little bit less. All right. Have a good one, my dudes.